All right, here I am. It is Monday afternoon, January 6th. I'm about 20 minutes late starting the stream, but I was actually over working on configuring some of the visuals in the store site that I'm using or that I will be using, and forgot to watch the clock or set myself an alarm or anything like that. Oops. So, and somehow I managed to trigger Siri on my watch, and I don't know why. So let's see here. This morning, we worked on the different implementations of the strategy pattern. And here's the expire subscription strategy. When we started, we did not have an implementation for the cancel strategy, so I had some tests failing. If you look down the left-hand side of my screen here, we have 21 of 21 passing tests. Let's run them again, just for laughs. Here we go, and they're all passing. So what I want to do is review a little bit of what we did in the last session. I was going to start implementing the API that is going to let outside callers, namely Lemon Squeezy, call a webhook and let me know whenever subscription change events happen within the system. Excuse me. But I got in here this morning and realized that I hadn't implemented the cancel subscription strategy at all. And then I got sidetracked into refactoring some of the more boilerplate code that was in place on the various other strategies that I've already implemented, like create and expire and renew. And I pulled those out and put them into the base class. Now, there's big debates happening in developer world over about injecting behaviors and composing your components from subcomponents that express the behaviors that your system might need versus inheriting common behaviors and so on and so forth. And I use both when it makes sense. So I've got this change strategy base. And when we started this morning, let's see if we can look at the history. Not here, but I bet if we go into my source control, I can dig around and look at my history. Not tags, not branches, not commits, changes. How about nope, here's my source control graph. I bet I can look at where are the details of my stuff here. This is just changes to the hashes. Here we go. Account manager constants, not really worried about that. App resource quota, not so worried about that. User resource quota, yeah. Change strategy factory. So I had added some things in here to the change strategy factory, namely some renews and stuff like that. Change strategy request, nope. Anyhow, the base class this morning didn't really have any implementations. All it had was a couple of protected abstract method declarations, namely just apply change. It might as well have been an interface. And then I got looking at the different child classes from this change strategy base, and I realized that apply change was basically the same from one implementation to the next. And the validate request was virtually identical from one version or from one inherited child to the next. And I was like, well, why don't we just pull these up in here and make apply change the same? Because the only difference, they all have to validate the request, and then after the request is deemed valid for both in terms of being well formed and in terms of being appropriate for the requested change kind, we perform the actual transformation. And then we take the new transform subscription, push it into the payload, set the change completed to true, and return the response. So validate request is the same from one kind of change to the next. So all we do is we make sure that, you know, the validator, the request itself is well formed, and then we make sure that the subscription action is well formed. The target template, it's hard coded, so it's going to be well formed. It doesn't change from one instance to the next. And then, of course, the subscription itself, I've got an abstract method declared on the change strategy base called validate subscription for change. Here it is. And then the rules to determine whether a subscription is in the correct state to be renewed or canceled or expire or what have you, those are different from one subscription and activity kind to the next. So the strategy classes, the actual concrete strategy classes, they implement their own rules. So looking at cancel, it has to be a renewable subscription type. You can't cancel a free subscription. All users of the system at least have a free subscription. Now, that's a rule I'm going to have to implement a little bit differently out in the customer builder, because when a cancel or an expire comes through, we need to get rid of the paid subscription and replace it with a new free subscription. So that's something that I haven't worked in yet, but we'll get there. It has to be in an appropriate state. We can't cancel an already canceled subscription. And I've got a helper class over in the SaaS admin framework that helps me with that. So we'll just go to the definition on there and valid target statuses. We've got a dictionary that gets created when this static class or when this class is instantiated. And then, of course, we have a method down here, can perform activity for status. We pass in the action name and the current subscription status, and it checks against that dictionary to make sure that the action is compatible with the current subscription status. I've got those little validation helpers scattered through. I'm using this validation helper throughout my code base, so it's in the project or the product IFX up in this project. We've got all that stuff in here. So all of the existing tests are passing, but we need to create a couple more tests to exercise a couple other scenarios. So let's come over here. Right now we have test cancel free unknown user. We expect a validation error. Test cancel free new user, expect validation error, because you can't cancel a free subscription. And we can't cancel a subscription for a user that we can't find in our systems. So what are some other scenarios? that we might encounter. And let's look at the expire ones. I'm just going to collapse these up to their headers here. Come on. Go. Here we go. And here we go. So we've got test expire free unknown, test expire free new user. We need test expire free user, expect validation, test expire active paid, cool, test expire expired paid, test expired canceled paid. So we need, hey, what's up, Z Films? Thank you, sir. Fact, public void, test cancel, free user, expect validation error. And I'm just going to leave these empty for the time being. And I'm going to go fact public void test cancel test cancel active paid user expect success. Get out of here. We're not implementing these yet. Fact public void test cancel expired paid user. I'm expecting a validation error. Fact public void. We're going to try to cancel a canceled user, and we expect a validation error. So this one's implemented. This one's implemented. These are not. Let's build. And there's all those. Refresh. And we're going to run them all. And those new ones are going to fail. Oh, all right. They passed because they haven't got any logic in them. That's okay. Let's implement the logic here. So I've got this thing called the test scenario builder. And that's a little something that I spun up during the holiday break to help me build out these scenarios, because it's basically just testing different combinations of user, subscription, and activity. So first thing we need to do is we need to create an instance of the iAccount manager. Manager to test equals configure test instance. And that's just a little helper class or helper method that creates new instances of the fake identity account, static catalog provider, blah, 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 the dependencies of the account manager, creates a new logger, and then instantiates a new customer account manager with those dependencies. And let's close the create, renew, expire. We're into cancel. Now our test scenario builder, this implements a builder pattern. Let's take a look at this. So it's building a managed subscription request and then the details that go into that subscription request. So it creates a managed subscription request and it's asking for the workload name. And the workload name that I'm passing in is just unit testing or something like that. Yeah. And we create a new subscription action detail. We set the vendor name to me, external service vendors at thatDeveloperDad. Here's the build method, scenario.payload equals action detail, return scenario. And then we've got all of these different things. These are all sort of extension methods that set up action details or different kinds of users, different kinds of subscriptions, and so on. And I'm using like constant values and stuff like that to create all of those different implementations of the or instances of the classes. And we're just building all of these things up. And then finally we call the build method. That returns the actual scenario that we want to test. So with request equals new test scenario builder, cancel free with brand new user build. The expected error is account manager constants, modify subscription errors. The requested activity is not valid for the current subscription type. This is what calls. So to put this into the AAA format for unit tests, arrange, act, get error messages into a string for easier debugging. Yep. And then finally, assert. Now, unit test purists would scream bloody murder that I'm making multiple assertions in my unit test. But why the heck would I execute the exact same thing 3 times just for the sake of having single assertions? All of these things have to be true for the test to be valid. And if one of them fails, it'll tell me. Back in the early days of unit testing, it was a lot of the unit testing frameworks didn't report really, really well when it came to reporting failed assertions. More modern ones, I'm using XUnit. It does a pretty good job of that. It does a fairly decent it handles multiple assertions fairly well, and in my opinion, it's good enough. I don't want to copy and paste and maintain 3 different chunks for the sake of having something that is, pure unit test stuff. It feels like just a whole pile of extra work. So var response, this one, free user, the requested activity is not valid for the current subscription type. That's the error message I want to see. And then we have to do the result because this is an async method. And then copy, paste, we're good. account manager, cancel paid with active paid user, build, good. Get the response, assert that the response is not null, subscription was updated, should be true, and assert dot true response dot has errors is false. It might have warnings. So, account manager, configure test instance, cancel paid with expired paid user. Expected error is requested activity is not valid for the current subscription status. Perfect. And I want to come up here and grab this string builder stuff. And just replace this code here. There we go. And paste. So yeah, if C-Films were here, I can't tell if he is or not, he would be talking about boilerplate, object-oriented stuff. Unit test code gets really, really repetitive and really, really, really boilerplate. But I want to run all these guys to make sure that we're still good. I might need to rebuild. Oh, we have some failures. Expired paid user. Subscription was updated. Equals false. Let's run in here and debug this test. Do I have errors? I have no errors. Excuse me, cancel paid with expired paid user. Oh, you know what? This is a valid scenario because somebody's subscription might expire because we tried to bill and we couldn't for whatever reason. Their payment failed or what have you. And it's a situation where, oh crap, I forgot that I need to cancel this subscription. So they go into the portal and cancel the subscription. Excuse me. And basically it just says, yeah, stop doing the thing. So this is a valid scenario. So let's update our expectations here. Assert.true, response.has errors equals false. The thing I wanted working. Yes. Yes, I did. I'm just adding in some some unit tests to make sure everything's good. Let's rebuild. And it's ready to go. Run everything. And I don't know why it's being a goofball. Let's run that. It's passing now. Expect success. We're not using expected error, so that's good. All right, and I want to run everything. Let's run test with coverage. I'm not going to do that. Let's just run all the things. 0 of 0. You dirty rat. Just run all the bloody tests in the project. Here we go. 25 of 25. Happy stuff. All right, so I'm going to come over to Git. Where's Git? Here's Git. Commit. Finishes implementing the cancel strategy. I'll add additional test cases for cancel scenarios. Commit. Sync. Off you go. Now, we've got 4 problems here, and I want to take a look at what they are. Modify subscription. They're just problems in the unit tests, but you know what? Compiler warnings are compiler warnings. And if it's null, I kind of want it to crash. Oh, jinkies. Save. There we go. Couple compiler warnings in the unit test project. There we go. No compiler errors, no compiler warnings. That's a happy thing. And let's go to GitHub. New window. GitHub. And we got to go into TDMF admin. Boop. Had recent pushes 22 seconds ago. Let's compare. We are able to merge. Here's all the stuff. The necessary subscription change strategies for launch are in place. With this PR. Create as a pull request. Assign myself. Projects. I don't think I have a project on this, do I? I do. Let's run in here. Projects. Let's add admin system. There we go. And merge pull request, confirm merge. All right. And let's take a look at our code. How many branches have I got? Implement manage subscription. Let's delete it. All right, back to VS Code. Let's flip to main. And I want to sync. And I want to do this. And I want to run them all. Groovy. Main. Create new branch from main. The branch name will be feature / create API project. Let's close our testing. Boop. And actually, I want to go back into Git and Git source control branch. I want to delete some of these old branches. Delete branch. Manage subscription. We can delete that because it's been pulled and deleted from origin. And now we have create API project. Creates branch to hold changes needed to create an API to expose the different account use cases. Publish. Off you go. Doesn't have any changes yet, but that's fine. Let's hide that. Bounce over here, and inside clients, we're going to add a new project. And it is going to be an ASP.NET Core Web API. Yeah. And I'm going to call it DevDad.SaaSadmin.API. Let's make sure it goes in the correct. Do this again. New project. ASP Core Web API. Try it again. I don't love the create new project experience in VS Code. DevDad.SaaSadmin.API. Enter. Let's make sure it's going in the directory that I want it to go into. So here's TDMF admin source, new folder, clients. not tests. Get out of here. New folder, clients. There we go. Open that. And it will be created in here, show all template object. There are options. Authentication type will be none. Configure for HTTP. Yes. Enable open API support. Yes. Do not use top level statements. True. Use controllers is false. And authentication type, we're going to roll with none. Create project. Yeah. Do it. All right. Got this HTTP, weather forecast, blah, blah, blah. Can't connect to the server, of course, because it's not running. And I guess we better set up a run and debug profile. So here's test console. C#, test console, not what I want. We need to add a configuration. And it's going to be more C# options. Neither of those. How about debug, start new instance? Let's just make sure it's running. Oh, it wants me to type my password. And it's off. Let's copy that. Pop open Safari. And I'll just pop this open. Apple TV, go. And there's nothing there. All right. It's about what I expect. We'll try going directly to the weather forecast get. And there we go. We've got output. Now with .NET 9, we no longer have Swagger or any of that stuff. We're also jumping the gun a little bit here because we don't know what shape the data is going to be in when it arrives from external colors. And because these are going to be callable by a webhook, that means we don't really have control over what shape the data will be in when it's submitted to us. So that means we've got a couple of different things that we need to worry about here. So here, this is this weather forecast class. We can get rid of it. Here's program CS. This is all boilerplate stuff that Microsoft stands up for us. So create builder, add authorization, add OpenAI, add OpenAPI. Okay, builder.build is development, map OpenAPI, use HTTPS redirection, auth, summaries. This is all fine and well and good if you just want a quick, dirty, little minimal API with like one area, etc., etc. Groovy. And we're going to mostly use this, but we're going to be doing a little bit of extra stuff with it. Now, I've got to bring in appsettings.json from elsewhere. That's fine. I'm going to need to bring in an environment file from my test console down here. I've got that .env, my app settings. I'm doing all kinds of custom stuff down here in program.cs. And this is mostly just invoking use cases and stuff. But I'm going to be porting some things in to the ASP.NET API program that I'm doing down in the console app so that I can use my system configuration, the utilities, the app architecture concept that I have in my thatDeveloperDad.ifx, this guy, because I've got a lot of helpers in here that help with the architecture and building the application up and making sure that dependencies belong to the components that depend on them and nobody else and stuff like that. It's a lot of DI protection, mostly protecting me from myself. So we have reached a logical stopping point. I'm going to probably continue work on this stuff for the rest of the afternoon, and any progress I make, we'll review it tomorrow morning and carry on from there. I also have to do some research about the shape of that data coming in and make some decisions about how I want the main application to communicate with this service or these components. Halfway thinking that I might incorporate these projects into the main GM Tools project. We'll see. I haven't fully decided yet. But until tomorrow, thanks for joining me. We got to review some inheritance, some refactoring, some unit testing stuff today. And tomorrow, we're going to start playing around with developing an API from quite literally the boilerplate scratch stuff that Microsoft gives us in that template. So until then, take care of yourselves and happy coding. Bye now.